installing voltage regulators to reduce voltage to 114 volts is unlikely to reduce lighting energy costs by 20%. Light output is not proportional to voltage. Lighting fixtures are designed to operate at a specific voltage range. Reducing voltage below this range can significantly reduce light output. Electronic ballasts contain voltage regulators that maintain a constant voltage to the lamps, regardless of the input voltage. Therefore, reducing input voltage will not affect the voltage supplied to the lamps. Lighting energy consumption is mostly determined by lamp wattage and runtime. The primary factor influencing lighting energy consumption is the wattage of the lamps and the duration they are operated. Voltage reduction does not significantly affect these factors. Reducing voltage to 114 volts could result in decreased performance and premature failure of lighting fixtures and ballasts. Lower voltage can also lead to increased voltage regulation issues, which can cause flickering or reduce light output. Operating electronic ballasts at lower voltages can reduce their efficiency, offsetting any potential energy savings. Reducing voltage to 100 volts or below would likely result in significant reductions in light output and prematurely age lighting components. It is not a recommended practice. Other measures, such as energy-efficient lighting fixtures, occupancy sensors, and daylight harvesting, are more effective in reducing energy consumption. Let's delve a little deeper into the concepts here. Firstly, understand that light output and voltage have a complex relationship that is not simply proportional. While it's true that reducing voltage can decrease light output to some extent, the relationship is not linear, and electronic ballasts play a significant role in modulating this relationship. Secondly, consider the design parameters of lighting fixtures. These fixtures are engineered to operate within a specific voltage range, typically around 120 volts in many applications. Operating outside this range could have detrimental effects on the fixture's performance, lifespan, and even safety. Thirdly, examine the functionality of electronic ballasts. These devices are designed to regulate the voltage supplied to the lamps, ensuring a consistent and stable light output even when the input voltage fluctuates. This regulation is achieved through internal circuitry that actively adjusts the voltage to compensate for variations in the input power. Fourthly, analyze the factors that primarily influence lighting energy consumption. Lamp wattage and runtime are the key determinants of energy usage in lighting systems. Reducing voltage alone does not significantly alter these factors, as the lamps will continue to draw approximately the same amount of power to maintain their light output. Fifthly, understand the potential consequences of reducing voltage to levels significantly below the designed operating range. This can lead to a cascade of problems, including decreased performance, premature failure of components, increased voltage regulation issues, flickering, reduced light output, and decreased efficiency of electronic ballasts. Now let's consider some more points in detail. Electronic ballasts are designed to provide a stable and consistent voltage to the lamp regardless of variations in the input voltage. This is achieved through a process called voltage regulation, where the ballast actively adjusts the voltage supplied to the lamp to compensate for fluctuations in the input power. Electronic ballasts typically contain a voltage regulator circuit that monitors the input voltage and adjusts the output voltage accordingly. This circuit ensures that the lamp receives the correct voltage even if the input voltage varies within a certain range. The voltage regulator circuit typically consists of a combination of electronic components such as diodes, transistors, and capacitors, which work together to maintain a constant output voltage. When the input voltage increases, the voltage regulator circuit reduces the output voltage to prevent the lamp from overheating or being damaged. Conversely, when the input voltage decreases, the voltage regulator circuit increases the output voltage to maintain the lamp's light output. The voltage regulation capabilities of electronic ballasts can vary depending on the design and specifications of the ballast. Some ballasts may be able to regulate the voltage over a wider range than others. However, most electronic ballasts are designed to maintain a stable output voltage within a tolerance of plus or minus 5%. In addition to voltage regulation, electronic ballasts also provide other benefits such as improved energy efficiency, reduced flicker, and longer lamp life. These benefits make electronic ballasts a popular choice for lighting applications in commercial, industrial, and residential settings. The energy consumption of lighting fixtures is primarily determined by the wattage of the lamps and the duration they are operated. While voltage can have some impact on energy consumption, it is not the primary factor. The relationship between voltage and energy consumption is not linear. While reducing voltage can decrease energy consumption to some extent, the reduction is not proportional to the voltage decrease. For example, reducing the voltage by 10% may not necessarily result in a 10% reduction in energy consumption. Electronic ballasts play a significant role in regulating the voltage supplied to the lamps. These ballasts are designed to maintain a constant voltage to the lamps, regardless of variations in the input voltage. Therefore, reducing input voltage may not significantly affect the voltage supplied to the lamps, and consequently the energy consumption of the lighting fixture. The wattage of the lamps is the primary determinant of energy consumption. Lamps with higher wattage consume more energy than lamps with low wattage. Therefore, reducing the wattage of the lamps is a more effective way to reduce energy consumption than reducing the voltage. The duration that the lamps are operated also has a significant impact on energy consumption. The longer the lamps are operated, the more energy they consume. Therefore, reducing the runtime of the lamps is another effective way to reduce energy consumption. Energy-efficient lighting fixtures, such as LED lamps and fixtures, can significantly reduce energy consumption compared to traditional lighting fixtures. These fixtures use less energy to produce the same amount of light, resulting in significant energy savings. Occupancy sensors can be used to automatically turn off lights when a space is unoccupied. This can significantly reduce energy consumption in areas that are not constantly occupied. Daylight harvesting systems can be used to automatically adjust the lighting levels based on the amount of natural light available. This can reduce energy consumption by using less artificial light when natural light is sufficient. Reducing voltage to 114 volts could have negative impacts on the performance and lifespan of lighting fixtures and ballasts. Reduced light output. Lowering the voltage supplied to the lamps can reduce their light output, making the space dimmer and less comfortable. Premature failure of lighting fixtures and ballasts. Operating lighting fixtures and ballasts at lower voltages can stress their components, leading to premature failure. Increased voltage regulation issues. Lower voltage can exacerbate voltage regulation issues, which can cause flickering or reduce light output. Reduced efficiency of electronic ballasts. Operating electronic ballasts at lower voltages can reduce their efficiency, offsetting any potential energy savings. Reduced lifespan of lamps. Lower voltage can also reduce the lifespan of lamps, requiring more frequent replacements. To achieve significant energy savings in lighting systems, consider the following alternatives. Replace traditional lighting fixtures with energy-efficient LED fixtures. LED fixtures use significantly less energy than traditional fixtures and have a longer lifespan. Install occupancy sensors to automatically turn off lights in unoccupied areas. This can save a significant amount of energy, especially in areas that are not constantly occupied. Implement daylight harvesting systems to automatically adjust lighting levels based on the amount of natural light available. This can reduce energy consumption by using less artificial light when natural light is sufficient. Optimize lighting schedules to ensure that lights are only on when needed. This can save energy by avoiding unnecessary lighting. Regularly maintain lighting systems to ensure that they are operating efficiently. This includes cleaning fixtures and replacing lamps as needed. Reducing voltage to 100 volts or below is not recommended due to the following potential consequences. Significant reductions in light output. Lowering the voltage to such a low level can significantly reduce the light output of the lamps, making the space very dim and potentially unsafe. Premature aging of lighting components. Operating lighting components at such low voltages can stress them and lead to premature aging and failure. Malfunctioning of electronic ballasts. Electronic ballasts may not be able to operate properly at such low voltages, leading to flickering or complete failure. Potential damage to lighting fixtures. The low voltage can potentially damage the lighting fixtures, requiring costly repairs or replacements. Safety hazards. In some cases, operating lighting fixtures at such low voltages can create safety hazards such as overheating or electrical shock. Energy-efficient lighting fixtures, occupancy sensors, and daylight harvesting are more effective measures for reducing energy consumption. Energy-efficient lighting fixtures use less energy to produce the same amount of light as traditional fixtures. This can result in significant energy savings. Occupancy sensors automatically turn off lights when a space is unoccupied, saving energy by avoiding unnecessary lighting. Daylight harvesting systems automatically adjust lighting levels based on the amount of natural light available, reducing energy consumption by using less artificial light when natural light is sufficient. Therefore, installing voltage regulators to reduce voltage to 114 volts is unlikely to reduce lighting energy costs by 20%. Other measures, such as energy-efficient lighting fixtures, occupancy sensors, and daylight harvesting, are more effective in reducing energy consumption. In conclusion, while the idea of reducing voltage to save energy might seem appealing, the reality is that it's unlikely to deliver the promised results and could even have negative consequences. Electronic ballasts, lamp wattage, and potential fixture damage are key factors to consider. Focus on more effective energy-saving options like LED lighting, occupancy sensors, and daylight harvesting to achieve meaningful reductions in your energy consumption.